solve some examples. Obtain the Maclaurin series of y equal to e power x over e power x plus 1. Y equal to e power x over e power x plus 1. So y at 0, e power 0 is 1. So that is 1 by 2. We can write this as e power x plus 1 into y equal to e power x. Let us differentiate. E power x plus 1 into y1 plus y, derivative of e power x plus 1 is e power x, is equal to e power x. Y1 into e power x plus 1 equal to, we take on this side, e power x 1 minus y. Therefore, y1 equal to e power x into 1 minus y over e power x plus 1. But this e power x over e power x plus 1 is y. So this is y into y1 minus y. So basically y1 equal to y minus y square. And therefore y1 at 0 equal to y at 0, and y at 0 is 1 by 2. Minus again y at 0 and its square. So 1 by 4. So that is equal to 1 by 4. Now we differentiate. So that is y2 equal to y1 minus 2y y1. And y2 at 0, y1 at 0, that is 1 by 4, minus 2, y at 0, that's 1 by 2, and y1 at 0, that is 1 by 4. So this is 1 by 4 minus 1 by 4, so that is 0. Again differentiate. Y3 equal to, derivative of y1 is y2 minus 2, derivative of y is y1. y1 is already there, so that is y1 square minus 2y, and derivative of y1 is y2. So y3 at 0 is equal to y2 at 0, that is 0, minus 2, y1 at 0 and its square. Y1 at 0 is 1 by 4, and its square is 1 by 16. And here also we'll have y2 at 0, which is 0. So this is minus 1 by 8. Now it is easy. You can find y4 also, derivative, and that is y3 minus 2 and 2 here, 4 y1 and y2. And here also you have derivative 2 y1 y2. So 4 and 2. So that is minus 6 y1 y2 minus 2 y y3. Therefore y4 at 0 is y3 at 0, that is minus 1 by 8. Now y2 at 0 is 0. Then minus 2, y at 0 is 1 by 2, y3 at 0 is minus 1 by 8. So this is nothing but minus 1 by 8. And this is minus minus plus to cancel 1 by 8, and so that is 0. We can again differentiate. We can find y5. That is nothing but y4 minus 6. Derivative of y1 is y2. y2 is already there. So y2 square minus 6 y1 y3 minus 2 y1 y3. So minus 8 y1 y3 minus 2 y y4. Therefore y5 at 0, y4 at 0, 0, y2 at 0 is also 0, minus 8, y1 at 0 is 1 by 4, y3 at 0 minus 1 by 8, and y4 at 0 is 0. So only this. So this 8 cancel, negative, negative, positive. So that is 1 by 4, and so on. So the Maclaurin series is y at x equal to y at 0 plus x y1 at 0 plus x square by factorial 2 y2 at 0 and so on. X cube by factorial 3 y3 at 0, x power 4 by factorial 4 y5 at 0 and so on. Y4 here. And so for us, therefore, that is nothing but e power x over e power x plus 1 y at 0, that is 1 by 2, plus x y1 at 0, y1 at 0 is 1 by 4, y2 at 0, 0, so this second term 0, plus x cube by factorial 3, y3 at 0, and y3 at 0 is minus 1 by 8, then plus x power 5 by factorial 5, that is 120, this is 6, y5 at 0 is 1 by 4, y4 at 0, 0, and so on. So therefore e power x over e power x plus 1 equal to 1 by 2 plus x by 4, then minus 8 6 are 48, x cubed by 48, then this is 120 into 4. So x power 5 by 480 and so on. So that is the series of e power x over e power x plus 1. Let us take one more example. Obtain the expansion of 1 plus x square over 1 plus x power 4. So 1 plus x square over 1 plus x power 4. This we can write as 1 plus x square over 1 plus x power 4 power minus 1. And we know that 1 over 1 plus x or 1 plus x power minus 1 is 1 minus x plus x square minus x cube and so on. So this we can use 1 plus x square, 1 minus x power 4, here in this case x is x power 4, plus x power 4 square and minus x power 4 cube plus and so on. So this is 1 plus x square into 1 minus x power 4 plus x power 8 minus x power 12 plus and so on. So this is equal to 1 into this. So 1 into this bracket. So 1 minus x power 4 plus x power 8 minus x power 12 plus and so on, plus x square into this bracket. X square into 1 minus x power 4 plus x power 8 minus x power 12 plus and so on. So this is equal to 1. Then this is x square into 1. So plus x square. Then minus x power 4. Then this is x square into x power 4. So x power 6. So minus x power 6 plus x power 8. Then x power 2 into x power 8. So plus x power 10 and so on. So that is the series of 1 plus x square over 1, 1 plus x square over 1 plus x power 4. Next, expand square root of 1 plus sin x. So here, root of 1 plus sin x, this we can write as 1 as a sin square x by 2 plus cosine square x by 2, and sin x we can use the formula sin 2x, 2 sin x cosine x. So sin x is 2 sin x by 2 cosine x by 2. And so this is nothing but sin x by 2 plus cosine x by 2 and its square. And so we have sin x by 2 plus cosine x by 2. Now the series of sin x is x minus x cubed by 3 factorial plus x power 5 by 5 factorial and so on. And we need series of cosine x also. That is 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on. So sine of x by 2. So series of sine of x by 2 is x by 2, then minus x by 2 cube over 3 factorial and so on, plus series of cosine x by 2. 1 minus x by 2 square by 2 factorial plus x by 2 power 4 by 4 factorial and so on. So now this is equal to 1 here, then x by 2, 1x by 2, then here x square by 4 and 2 here, so minus x square by 8, then this is minus x cube. Now 2 cube is 8 and 6 here, so that is 48 and so on. So plus here x power 4, 2 power 4 is 16, 4 factorial 24, and so that is 16 into 24 is 384. So this is 384 and so on. So this is the series of root of 1 plus sin x. Next, expand cosine square x. So we know the formula that cosine square x is equal to 1 plus cosine 2x by 2. And this is equal to 1 by 2, 1 plus. Now the formula for cosine x, Maclaurin series of cosine x, that is 1 minus x square by 2 factorial plus x4 by 4 factorial and so this is a 1, then minus, now we have 2x. So 2x square by 2 factorial, 2x power 4 by 4 factorial, and so on. So we have, this is 1 by 2, this is 2, minus 2 square is 4, this is x square, 2 factorial is 2, plus 2 power 4, 16, x power 4, 4 factorial 24, and so on. So this is equal to 1 to cancel now. 1 minus x square, then plus 2 and 8, and 8 3s are 24. So plus 1 by 3 x power 4 and so on. So this is the series of cosine square x. Similarly, you can find yourself by series of sine square x, that is 1 by 2, 1 minus cosine 2x. So you can try and you can find out. You will get the answer as x square minus x power 4 by 3 plus 2 by 45 x power 6 and so on. Now we can find the series of, we can expand log of 1 plus sin x. So now log of 1 plus sin x. Now we know log of 1 plus x. Its standard series is x minus x square by 2 plus x power 3 by 3 minus x power 4 by 4 and so on. So log of 1 plus sin x. So log of 1 plus sin x is sin x minus 1 by 2 sin square x, then plus 1 by 3 sin cube x minus 1 by 4 sin power 4x and so on. Now this is equal to now series of sin x. So this is x minus x cube by 3 factorial and so on, minus 1 by 2 x minus x cube by 3 factorial and so on, and its square, 1 by 3 x minus x cube by 3 factorial plus and so on power 3 minus 1 by 4 x minus x cube by 3 factorial and so on power 4 and plus and so on. Now collect the term x. X is you will get only here. So that is x. Where do we get x square term? So x square term will get here. X, when we expand this, x square. So we'll get x square here. So that is minus 1 by 2 x square. Now see where we get x cube. So we'll get x cube as here. X cube 1 is here. That is a minus 1 by 6. And x cube will get here. X cube. That is 1 by 3. Then we find x power 4. We'll find x power 4 term. So x power 4, well, we'll get x power 4 as here. When we expand this, this is minus 2 times like this. Minus 2 times this x power 4 by 6. But here minus 1 by 2 is already there outside. So that to cancel, 2 to cancel. So we'll get 1 by 6. So 1 by 6 from here. We'll also get x4 from here, a minus b cube. So, no, not from here, but from here, x power 4. When we expand this, x power 4. So that is minus 1 by 4. And so on. So you have, this is x minus x square by 2, 1 by 3 minus 1 by 6 plus 1 by 6 x cube, 1 by 6 minus 1 by 4. So that is minus 1 by 12 x power 4 and so on. So this is the way we can find the series of log of 1 using the series of log of 1 plus x and for log of 1 plus sin x. So this is the way we can find out. We can take one more similar kind of example. Expand sine of e power x minus 1. Now sine of e power x minus 1. So this is nothing but sine of. Now e power x series is 1 plus x square by factorial 2, x cube by factorial 3 and so on. And minus 1. So this 1 will be getting cancelled. So we'll get x plus x square by factorial 2 plus x cube by factorial 3 and so on. This is sine of this one. Now again we use the series of sine x. So what is the series of sine x? Sine x is x minus x cube by factorial 3 and so on. So this is our whole x. So this is x plus x square by 2 plus x cube by 6 and so on. So this is x. Then minus 1 by 3 factorial and x cube. So that is x plus x square by 4, x cube by 6 plus and so on, its cube and so on. Now we collect some term. So x is here. Then x square is also here. Now we don't get any x square. So x square. So 1 by 2 x square. Now x cube will get 1 by 6 here. And x cube will get here. That is also minus 1 by 6. Plus x power 4. X power 4 will get from here also, like next x power 4 will get so here we'll get x power 4 one term here. After this we'll get x power 4 by 24. So x power 4 here 1 upon 24 4 factorial. Okay. Then here we'll get x power 4 here like x That is like minus 1 by 3 here. Minus 1 by 3 factorial, that means minus 1 by 6. Then 3 a square b, a plus b cube. A plus b cube will get one term like 3 a square b. So this is 3 a square means x square. B means x square by 4. So this term will get 3 to the 6 minus 1 by, and this a square and b. So we'll get like this. This is 3 factorial. So this is 6. And so minus 1 by 3 factorial. So that is minus 1 by 6. Then 3. Then a square. So x square. And b. This is x square by, sorry, 2 factorial. So 2 is there. So x square by 2. X square by 2. So 3 to the 6, 2 and 2, 4. So 1 by 24 minus 1 by 4 plus and so on. So we have sine of e power x minus 1 is equal to x plus x square by 2. Then this is 0. Now simplify 1 upon 24 minus 1 upon 4. And that is nothing but pi over 24, but negative sign. So minus pi by 24 x power 4 plus and so on. So these are the kind of examples where we can use the non-series to find out the series of some